How universal motors work on both AC and DC. Welcome to this presentation. Today, we'll learn how universal motors are designed to operate efficiently on both alternating current and direct current. We'll look at their working principle, construction, and how they maintain torque in both supply types. Introduction. Universal motors are unique because they can run on either AC or DC supply. Their design combines the characteristics of DC series motors with special adaptations for AC operation. This dual compatibility makes them ideal for portable appliances. Basic principle. The basic principle behind a universal motor is torque generation. When current flows through both the field and armature windings, magnetic fields interact to produce torque. Importantly, the direction of torque stays the same whether the supply is AC or DC. Operation on DC supply. Under DC supply, current flows in a single direction through both the field and the armature. This creates steady magnetic fields that interact to produce continuous torque. The commutator ensures that the current direction in the armature stays correct for smooth, constant rotation. Operation on AC supply. When running on AC, the supply current reverses every half cycle. However, since both the field and armature currents reverse simultaneously, the direction of torque remains the same. As a result, the motor continues to rotate in one direction without interruption. Role of commutator and brushes. The commutator is crucial because it reverses the armature current at just the right time to maintain the correct torque direction. Brushes provide continuous electrical contact with the rotating armature, allowing smooth and consistent rotation whether the supply is AC or DC. Design considerations. To make the motor efficient on AC, the core is laminated to reduce eddy current losses. The field and armature windings are connected in series so that they carry the same current, ensuring proper torque. This design helps the motor achieve high torque and speed in a compact form. Advantages of dual compatibility. Because they can run on both AC and DC, universal motors are flexible and practical. They deliver high speed and torque, making them perfect for devices like mixers, drills, sewing machines, and vacuum cleaners. Summary. In summary, universal motors maintain constant torque regardless of the power source. They achieve this by simultaneous reversal of current in the field and armature windings, assisted by the commutator. Their dual compatibility and high performance make them a popular choice for many portable electrical appliances.